Welcome back to Rod's Radios. On the bench today is a real little cutie. Look at the size of this little radio. It's a PYE Model 534 and I haven't been able to find the exact service sheet for this, so I'm going to be at a bit of a loss when I start looking at this. However, it looks like a nice little radio. It's an AM radio, medium, long wave and short wave, one shortwave band. And we have volume control here on the front, tone, no waveband switch, and just tuning. So just 3 controls. Let's turn it around the back and see what's inside. So let's have a closer look at this. I can see that it is 3 valves. There's no mains transformer in it, so this is what's called a hot chassis set. So I'm going to have to be a little bit careful, and I'll definitely only connect this through an isolating transformer for safety reasons. These are not good if you get an electric shock from the mains, because depending on which way the mains plug is plugged in, if it's a 2-pin plug, this chassis could be live. So let's get the chassis out and have a look. I did plug it in earlier and there's a low crackling noise right across the wavebands, but absolutely no reception whatsoever. So chassis out and let's start taking some measurements. I've managed to find a similar radio to the model on the bench here from Radio Museum, and it's listed as a PYE R33. It looks very similar from the outside, and the circuit diagram is virtually identical, except for the fact that it seems to have an auto transformer at the beginning of the power supply rather than the dropper resistor in this radio. And the first thing I've noticed is the B plus is way off. The B plus is coming out of a diode. It looks like a selenium diode, and when I look at the chassis, in fact it is, yes, it's a selenium diode. And the B plus is listed on this particular radio as 225. However, I'm only measuring 146 on this, so perhaps it's as simple a problem as just the selenium diode being faulty. So let's whip it out and test it. The selenium diode is out on the bench now, out of the radio, and connected up to my analog ohm meter here. And it's measuring 800 k ohms forward resistance, so that's not good, and certainly I think would account for the low B plus voltage. So I'm going to replace it with a little silicon diode, a modern IN4007 diode instead, this little beauty. Now it may mean that the B plus voltage is going to be a lot higher, because typically these selenium diodes were very inefficient compared to the modern silicon diode, so I may have to put a resistor in series to compensate for the HT voltage, which may be too high. However, let's try it on its own and see what happens. I've fitted the new silicon diode, the IN4007, in place, and I've fitted it onto a tag board located in the same position as the original selenium rectifier. And I took the opportunity while doing this to replace some of the paper capacitors which have been probably leaking or starting to leak since the day this radio was fitted. There's another one up here which I will replace, and 1 or 2 on the top side. And as you can see now, I have a very healthy B plus voltage within a volt or 2 of the specified on the circuit diagram. And as you can possibly hear in the background, I have a very noisy Radio 5. But this radio is now working. So I'll just replace the rest of the capacitors, check the alignment, and hopefully we have a fixed radio. The radio is now working well. However, there is one exception, and I mentioned this at the beginning of the video, in that at a certain level of the dial reaching this point here, there's a crackling sound intimating that the vanes on the tuning capacitor are rubbing. Now, I've tried in vain to sort this out by bending out the outer vanes on the tuning condenser, blowing in compressed air. However, it's still showing the same effect. So I'm going to have to physically take it out and look at this tuning condenser a little bit more closely. With the tuning capacitor out on the bench, I was able to fiddle about with it for about a half an hour before I thought I had it working, at which point I put it back into the radio. But it was exactly the same. So once more, out onto the bench and fiddling around with it again, and eventually I now have a situation where tuning from top to bottom, there is no rubbing between the outer and inner vanes, and this tuning capacitor is now working. This is more or less the component count that I ended up replacing. There was one other section that I didn't show here. It was one of the HT dropper smoothing capacitor sections that was a little bit out of kilter, resulting in some hum on the radio. So I've replaced that as well. And now it's time to put the chassis back into the radio and check it out. I didn't mention previously that this radio dates back to around 1959, so it's pushing on for 65 years now at this stage. Let's hear what it sounds like, although there's not much in the way of AM reception here in Ireland, as I would have mentioned previously. But if I turn it up...
That's a nice position. Jackie knows her phone is charging and she'll be ready to smash out the selfies come Tanya's 30th later.
We're listening to one of the few radio stations available from AM on medium wave on the broadcast band, and this one comes from the UK, so it's bound to be noisy and crackling, as you can hear. Other than that, there's very little to hear on an AM radio here. However, there may be some shortwave reception, which I'll select the shortwave band. Let's see if I can tune in anything from shortwave. I think that's Chinese radio. So that's it. Now I will get a lot more reception towards the evening. It's morning time here in Ireland at the moment. And as the evening approaches, the radio frequencies start to crash in, particularly on shortwave. So that's it for now. If you have been, thanks for watching.